Hello, good morning everyone. Thank you so much for joining. I'm Shreya, one
Good
of the
morning.
TAs for this course, and today I'll move on to week 5 concepts and I'll discuss a few problems. But before that, I think Ms. Janvi Prajapati has a question. Can you please tell me what your doubt is? I'll try to solve it. So you asked in assignment 5 questions approached by using R commands. For that we need to import data in R, and how can we import the same, because it is taking very long time. Okay, so how exactly are you importing it into a vector? Hello, I'm not audible. uh, Hello. Okay, I'll just okay, now is it coming right? But I think Janvi is still not online. Okay, okay. So this is one of the. Shall I wait for her to join, or what should I do? Okay, so if you feel that it is taking a long time to import vectors into R, one of the quicker solutions is to save it as a CSV file or as an Excel file and then read that file. I think that is an easier way to manipulate data. I'll just show you how to do it. But first of all, you have to tell me if you can see the entire screen or the R console that I'm talking about. Can you see my screen? All right. Can you please unmute yourself, and since we are only a couple of people, it will be better if you can unmute yourself and respond to the questions. So, and we're still not online. Fine. So, the question was, how do we input? If you have a vector like this, let's say you are entering 10 values. So, you could easily do it with C. Let's say 10, 20, 30, 40, 50, 55.4, 99, something like this. If it is 2 3 values, it is okay. But if you are not able, if there are, let's say, 100 or 200 values, it is not possible to manually enter. Or most of the times what is going to happen, even if you have 100 200 length data sets, these will usually be stored in some format. So my question is, if you do see that you have over 50 data points, I would request you to go to your Excel file and you give the name of the variable, let's say var1, and enter the data here, because entering something using comma, I think rather than doing that, it is better if you enter it in Excel sheet. So let's say if I, this is just a random data generating sequence. So if I just, let's say I have how many, sorry, so I have 89 or let's say 91 data points or 90 data points as such. All right, let's say I have 90 data points. So what I'm going to do is I'm going to save this file as a CSV file. Let me save it in desktop. uh, Data entry demo. The easiest thing to do is to save it as a CSV file. You could also save it as an Excel, as a tab separated, tab delimited file, but I would rather go for a comma separated or CSV file. So I saved this file, and then when you go to R, you just have to first set your working directory. So this command set will help you set your working directory. All right, so the command is setwt. So now you have to go to your file. I think Janvi Prajapati has joined. Janvi, can you hear me?
Yes, ma'am.
Okay.
I have asked one question.
Yeah, I am in the process of answering that. So your question was, if we have too
Okay,
many
sure.
numbers, uh, how are we going to enter it efficiently? Is it correct? In a
Yes,
less
yes, ma'am.
time taking manner. Okay.
Hmm.
So my suggestion to you is, during exams, mostly you will be given something which won't be too lengthy. But even if you are given something very lengthy, my advice to you is just save it in an Excel. Just write it down in an Excel sheet. Okay, right, like here I have, can you see here the count? I have 90 data points, count equal to 90.
Yes, ma'am.
Okay, so
Yes.
if I go to R console, and then if I try to write it 90 times comma separated, I think this is a little bit of a hassle, because I have to write C, and then if I have, let's say, texts, then I have to put everything in double quotes to save it as a text data. I mean, to have something of this, some character vector. So this is time taking, and this is a little inconvenient for me. So my suggestion to you would be, go to an Excel format, go to an Excel sheet, and you enter the data into one column. If you have 2 3 data points, just enter into 2 3 columns, and then you save it as a CSV file or a .txt file, whichever is convenient for you. Okay, either a text file, tab delimited text.txt, or a comma separated values CSV file. Now once you save it, it will be easier to import data. So I have saved this file as data entry demo, and it's saved in my desktop. Okay, so I'm going to go to desktop, and I'm going to see the file path. So the file path for me is this thing. Okay, so I'll just go and set my working directory to this path. All right, once I set there, next I am just going to load x equal to, I am going to do read.csv, and I am going to enter data entry demo.csv. So once I do that, I am going to get this data frame. With variable 1, I would have 90 observations on one variable, and then I can manipulate this data frame. The data structure will be different, but uh, I could do too many I mean, I can perform all the functions here. So can you tell me what all functions have you learned so far?
Uh, Ma'am, my question is that in assignment fifth, as we can't able to copy that file. So, to doing this or importing any variable in Excel file also, we have to do it manually. It is the
Assignment
same process, no?
assignment 5 you are saying, right?
Hmm.
I'll just check.
Means most of the question are can we do by using the commands, our commands, like for this uh, like fifth question, I think. Fifth question, fifth or sixth.
Hmm.
Yes, fifth for this fifth, sixth question on sixth.
Okay.
Yes,
Hmm.
ma'am. How can we import this data? Means if we using all dot moments command. Uh, first we need to import this data variable, or we have to store this variable into
Yeah.
some variable now.
Yes. See, this is
This
an assignment question, so there's no
hmm.
bound of time for you. So, in order to do this, you just have to save it as,
Yes, ma'am.
like, since it is not given, there's no other option but
Hmm.
to
Hmm.
do a C, and then you just save it
Hmm.
91.9 and so on
Yes,
and so
ma'am.
forth.
So this is
Okay.
very time taking now.
This is
That's
time taking, but
if
I don't think during
uh,
exams you will be given such a big data frame. All right.
okay,
And
okay,
even if you are
okay.
given something like this, I
Hmm.
personally feel it is better if you just enter it here. And 54.3, I think this would
But the
be
man
easier.
same process will also be done in manually, na? In Excel file
Yeah,
also we
yeah.
have to do it manually.
Ex-
The
that's true.
same
That's
process
true.
we are doing here
If you
also.
are given something like this, then
Hmm.
either you
Hmm.
have to, I mean, this is not, you cannot copy paste it. Or one
Yes.
easy solution is you can just take a screenshot, convert it to
Hmm.
a text file using online platforms, and then just copy it.
Okay.
This is one of the
Okay. Okay.
easier
That
methods.
is the
You just take
good
a
suggestion.
screenshot of
Okay.
this part and convert it
Hmm.
into, you use any image to text converter online. There are several softwares
Okay.
available. You use one registered
Hmm.
one, and then just enter this.
Okay. Then.
That would be
Okay,
a
ma'am.
little easier, I believe.
Thank you for the
Okay.
suggestion, ma'am.
Okay. Thank you so much. All right. So then shall I move on to the this week's?
Ma'am, I have a
Hmm.
question.
Yes, of course.
Actually, in the final
Hmm.
examination, shall we get the R software and we'll work on that, or is it only theoretical questions? Because do we get an R software there, or I mean any kind of access to that?
Uh, as far as I know, it would be theoretical, but I would request you to get check this with the NPTEL team,
Okay.
because they'll help you specify the specifications for this year. All
Okay,
right,
ma'am. And
you
another
just
thing
come.
is that, ma'am, the
Hmm.
thing that the examples that we are working with
Hmm.
right now, because they are very nice to, I mean, easy to understand and all. But when we are handling a huge amount of data, maybe there will be problems that we are facing. So my request is, if we could, ma'am, actually, this is the first class I'm attending problem solving session. Since I'm working, it's not possible for me to work on attend on weekdays. So
Okay.
if you could just show us with a huge bigger data set, that how R is working on that and how we do that with R, it would be helpful for us, because in a real life, like in if we apply it in practical world, we'll have a huge amount of data.
Yeah,
We'll
that's
not be
true.
working with smaller amounts. So it would be great if you could show us with, huge bigger data set.
All right, all right. So, one suggestion I could give you is that, see, this is a UG level course, and this is the target audience is very vast and very varied. So, there would be beginners and there would be working professionals like you who really work with big amounts of data. All right. So what I would suggest to you, I take your feedback positively, and in the upcoming sessions I would try to show this with bigger data sets, just to address this question. But I would also ask you to try it out using the data sets that are already given in R. Okay,
Okay,
so
ma'am. Okay, ma'am.
I think there is this cars data set. Yeah, see here you have a data frame. One second, I'll just ask data sets. If you just go to these R data sets package, you would find similar other data set. But okay, I understand your question. Maybe today, in today's session, I'm going to use a few. I'll show you how to import larger data sets and work with that. All right?
Oh,
Okay.
okay.
Okay. So before moving on to that, I had a few questions about that was yet to be solved last week. So I'm going to solve that and then move on to today's questions. All right? Okay. So we learnt about probability distribution functions and CDFs. Those things we have already learned. Now, if you have to solve such a question, how are you going to do that? You are given a problem and you have to design or develop the probability distribution of x. Then how are you going to do that? Okay. Now the question is, a shipment of 7 television sets contain 2 defective items. A hotel makes a random purchase of 3 of the sets. If x is the number of defective sets purchased by the hotel, find the probability distribution of x. So my random variable is defective TV sets. Alright, and x can take values from, could be 0, could be 1, it could be 2, but it cannot be 3 because in total there are 2 defective sets. Alright, now we have to find out the probability distribution, that is, what is probability x equal to 0, what is probability x equal to 1, what is probability x equal to 2. So x equal to 0 means there are 0 defective sets. So from what we are doing, we are making a random purchase or selecting 3 sets out of the total 7 television sets. Okay, so the number of ways we can do that is 7C3. And x equal to 0 means we are choosing 0 defective sets. So if we are choosing 0 defective sets, it means we are choosing all the 3 from the non-defective sets. So just calculate this and see what you get. 5C3 by 7C3. You can use R. Similarly, probability x equal to Similarly, probability x equal to 1 would be 1 we are choosing from this set and the remaining we are choosing from this set. Okay, and probability x equal to 2 would be 7C3. We are choosing 2 from the 2 defectives and remaining from the 5 non-defective ones. So whatever these values would come to, that would be the answer. That fx of, no, yeah, that would be the probability distribution. These would be small fx. Alright, is it clear? Shall I move on to the next one?
Yes, ma'am.
Okay. Okay, so if you are given a question like this and you are told that find out whether the following is or are a valid CDF or not. So for CDF, you remember the properties. Fx should be non-decreasing, f of infinity is 1, f of minus infinity is 0, and f of x plus is fx. That is, it should be right continuous. So if these 4 conditions are satisfied, we would say that this is a valid CDF. Alright, so let us see if these are valid CDFs or not. Now when C is towards 0, then the F1C is 0, and when C is greater than 3, it is 1. So these two conditions are followed. Now the next condition is this thing. So let us see if this is right continuous or not. Okay, so f1 is 0.5 into 1, that is 0.5. Okay, and f1 1 plus, that is also 0.5. So this is right continuous. So this CDF is a valid one. All right. This is a valid one. The next one is this one, f2c. So f2c also, f of minus infinity is 0, towards infinity when it's going it's 1, but it is not right continuous, because you see f2 of 1 is 0.5, but f2 of 1 plus is 0.75, which are not matching. So this is not a valid CDF. Okay, the next one, this one, f3. Okay, now f3 is not a valid CDF, because when f of minus infinity, when c is moving is less than 1, then this is not equal to 0. Okay, so there and there this criteria is not satisfied, so this is also not a valid CDF. Now the next one is this one. So here we see f of minus infinity is 0, f of infinity is 1. Okay, f is non-decreasing, 0, 0.5, 0.75, 1, and f of 1 plus is equal to 0.75, and f of 1 is also 0.75. So this discontinuity point, it's right continuous. Another discontinuity point is this thing, f of 3 plus is 1 and f3 is also 1. Alright, so this f4 is also a valid CDF. Is it okay?
Yes, ma'am.
Alright, fine. Now let us move on to this one. So here we are told that x is a continuous random variable with this PDF and y is a function of this random variable. Then you have to find the CDF of y. So if you are given something like this, how will you do? So CDF of y means probability capital Y less than equal to small y. Okay, this we can write as probability, instead of capital Y, because capital Y random variable is equal to x square, less than equal to small y. Okay, we can write this as minus root over y less than equal to x less than equal to root over y. Do you understand this step from this step? So if x square is less than 4, x can lie between minus 2 to plus 2. Right? Because if you do minus 2 square, that is also 4, and 2 square is that is also 4. Alright, and this is an increasing function. Sorry, y equal to x square will be this one, this parabola. Oh, sorry. It would be this. X is minus 2, that time also it's 4, x is plus 2, that time also it's 4. Anyway, so this translates to this, and now we just have to write it like this. Minus root y to plus root 5 fx of dx. Now fx of dx, if we just write it down, it will be minus root y to plus root y half of e to the power minus mod x dx. Okay, this we can write as minus root y to plus root y half e to the power minus mod x dx. Now this is a even function. What do we mean by even function? Even function means that f of x is equal to f of minus x. This part. Okay. This is an example of an even function. Even if you put plus x here, it would come, if you put plus 4, it will be half e to the power minus 4. Even if you put minus 4, since it is a modulus sign, it will also be half e to the power minus 4 only. So f of any z will be equal to f of minus z. So if you have something like this minus a to a f z dz, where fz is a even function, then you can write it as 2 into 0 to root y half e to the power minus mod x dx. You can write it as 2 into 0 to a fz dz. Okay, this is a property of even functions. Now since the value of x ranges from 0 to root y, we can write this as 0 to root y half of e to the power minus x. The modular sign then it becomes redundant. Alright, and then we can write it as 2 0 to root y half e to the power minus x dx. This 2 cancels. We have 0 to root y e to the power minus x dx. This we can write as the power minus x 0 root y. Okay, so substituting root y, we have minus e to the power minus root y minus of e to the power 0, that is minus 1. So this is 1 minus e to the power minus root y. So therefore the answer to this question is f of fy of y is equal to 1 minus e to the power minus root y when y is greater than 0 and 0 otherwise. That is this thing. Okay. Is it clear? If you are given some function gx, then you just have to put gx over here and then proceed with the definition of CDF to land up at the CDF of the function. Is it okay? Alright. So if you're okay with this, I'll just move on to week 5's questions. So in week 5 we learnt about expectation, and also we learnt about moments, special cases of expectation of a variable which are used to describe features of the distribution. And there are 4 key features that moments would help us determine. So first feature is a feature of the central tendency, where the median or mean value of the distribution is centered. The second is measure of dispersion or spread. And also we learnt about skewness, which tells us how the shape of the distribution looks like. And then we learnt about kurtosis, which is a measure of pickedness of the distribution. Okay, so just to give a brief, let's say we have a distribution something like this. Okay, the data points are scattered over here. So this central figure somewhere here, around which all the points are clustered, this would be a measure of my central tendency, some mean or medium value. Okay, and this area, how it is spread, this spread would be given by measures of dispersion. Okay, so for example, if we have a curve like this is spread from -3 to +3, let's say. Again, if we have a curve like this, which is spread from -2 to +2, so this has lower spread or lower variance compared to this one, because dispersion is giving us a measure of the spread. All right, okay. And also we learned about skewness. So skewness is giving us how the distribution looks like. So if we have something like this, where here we have the x values, here we have the frequency values, so this is positively skewed. Okay, and if we have something like this is negatively skewed. This is negatively skewed. Okay, positive skewed means what? At lower values of x we would have higher frequency, and negatively skewed means at higher values of x we would have higher frequency. So this one means lower values of x at high frequency, and here we would negatively skewed means this means high values of x at high frequency. So if I give you an example, let's say along x axis I plot incomes. Okay, and along y axis I plot frequencies, and my population under consideration is, let's say, the Indian population. Okay, so how do you think this curve would look like? Will it be a positively skewed curve or will it be a negatively skewed curve? Just guess. Try to make a guess about it.
It will be positively skewed.
Yeah, okay. And why do you say so?
Because at more people are in lower incomes, so
Yeah,
that is why with low frequencies it will be more number of people
exactly.
with low income.
Exactly. So since this is we are still a developing country, and there would be more number of people with lower income groups and only a handful with too much of high income. All right. So can you give me an example of a negatively skewed graph where there would be something like a negative skewed graph, and any example?
We can continue with the same example, like more income and more spending.
No, I just want the frequency of, what should I put? Incomes I cannot put. You're trying to
Yeah.
say frequency of spending.
Yes.
So if frequency of spending, lower income, so if the population is Indian population, then people who earn less, they spend less only, no, comparatively.
Ma'am, with that rate, we can draw negative skewed graph. Uh,
With what should be x? Can you give me an example of x?
Means in today's scenario, and with death rate will be the y-axis, and x-axis
No,
with
y axis will be frequency. We are only
okay,
considering univariate cases, okay? So
okay.
y axis would be frequency, x axis, how about, let's say my population is um, let's say my population is consisting of people who have uh, whose lifestyle is such that who are more prone to obesity, let's say. Okay, now if I get a plot of BMI, and if my set is this thing, then I would have larger frequency of people with higher BMIs because my population is obesity prone. Is this acceptable to you?
Yes.
Okay, so
Yes, yes.
okay, so this is a measure of skewness. Now why do you think we need to learn about whether a graph is skewed or not? Because skewness has several implications. For example, let's say when you have a positively skewed graph, let us consider our income example. Okay, we have income along x-axis and frequency along y-axis. So if you have a very skewed distribution like this, and your question is find the average income of the population. Okay, so if you do a simple average, because of presence of millionaires and billionaires, maybe the true measure, if you have to measure, get a measure of the central tendency, ideally it should be something around here, right? All incomes, because higher groups are clustering in this area, it the this should be the true average income, let's say. Why is it not reducing? Huh. So my true average would be somewhere here. But due to the presence of such extreme values, my mean would be the estimate, or the result that I would get from mean would be this one. This would be my observed thing, which would not be a true representative of the current income scenario in the country. Because we have too high a number here, they will pull the mean towards themselves. So if we have such skewed distribution, mean is not a good measure of central tendency. Okay, you could see calculating mean is nothing. You just input and just give a mean command and you are going to get a result. But when you apply these data sets to real life, if you have a very skewed distribution and then you say that the measure of central, you report mean as a measure of central tendency, then you would be biased towards the extreme ends. That would not reveal the true picture. Similarly, in this case, in this BMI example that I gave you, maybe the centrally the points are clustered around this point. Okay, but due to 1-2 figures which very low BMI, let's say less than 20, this would be pulled towards itself. It would come somewhere here. All right, so then that would also not, in case if I am trying to represent a population prone to obesity, and then I am saying that no, they are all fall in the normal range, I would be giving a wrong answer. It would not be indicative of the true picture that is prevalent. So in such cases, when we have too skewed a distribution, the preferred, so here the note is that if we have skewed distributions, mean is not an appropriate measure of central tendency. So if mean is not an appropriate measure, then what should we do? We should opt for median instead. Now what median would do? So the concept of median, if you have learnt about quantiles, I think you have learnt about quantiles, right? So median means such x, such an x, such that 50% of data points lie below x and 50% of data points lie above x. Okay, so this is what it actually is doing, is that it is dividing the entire data set into two parts, such that, so this is giving a true representation of a mid value. This is giving a mid value, that see 50% observations, 50% of the population is below this level, 50% of the population is above this level. So this is a better measure for median when for central tendency when we have extremely or reasonably skewed distributions. Is it okay? All right.
Yes, ma'am.
Okay. So we learned about this, and then what else we learned about? We learned about kurtosis, or a measure of peakedness of the distribution. So if you have, so kurtosis is compared even with skewness. If we have skewness coefficient equal to 0, this would be a symmetric graph. So this would have a skewness of 0. Alright. So anything which is deviating from this bell-shaped symmetric curve, that would give a measure of the deviation from symmetry, would give you a measure of the skewness. Now you might have heard about a normal distribution. Okay, so a normal distribution is, it looks something like this. It is symmetric and it is also called mesokurtic. Now if we have uh, a distribution which has thinner tails and high peaks, then such a curve will be called lepto or platy.
Leptokurtic.
Yes, such a curve would be called leptokurtic. And if we have another curve which we have thicker tails but less peak, this would be called platykurtic. Okay, and all of these, apart from mean, variance, the skewness coefficients and leptokurtic, platykurtic coefficients, or kurtosis coefficients, all can be calculated with the help of moments. So moments can be of two types, raw, and it could also be central. Okay, raw moments usually are expectation of x to the power r, which is nothing but if x is discrete and if x is continuous, it would be 1 by n summation xi to the power r probability xi equal to xi, and it would be integration of x to the power r fx dx if x is continuous. Alright. So central moments are what? Central moments are usually expectation of x minus a whole to the power r, and most usually a is usually the mean. Okay, so this would be mean deviation from a mean deviation raised to the power r and expectation of that, and this would, then this thing would become gx and expectation gx formula would follow. Is it okay? And also we learnt about degenerate distributions where the mass is concentrated at one point. The CDF of degenerate distribution, and we also learnt about discrete uniform distributions. So with that, let us move on to the questions. Okay. Also we learnt a few things about property.
Ma'am, can you show us how the degenerate distributions would look like if plotted on a graph?
Okay. Degenerate distributions. So it means that probability x equal to c is only 1 and any other point is 0. Okay. So the CDF would look like, it would look something like this. So this is the CDF of x. At till c, the graph would be this. Okay, at 0. And at c, it would become 1.
Okay.
This is how the CDF would look like. That probability, when x less than c, it would be 0. X greater than equal to c, it would be 1. This is your point of discontinuity. And here only the mass is concentrated. We have probability x equal to c is at 1. Okay, all right. And also we
That's
learned about discrete uniform distributions. So discrete,
And ma'am, PMF will be a point on the graph uh, for degenerated function.
degenerate functions point on which graph?
Means CDF graph will be just you have shown to us,
Hmm.
and PMF will be the point. Or for CDS, you just draw a line, continuous line,
Hmm.
and PMF will
So
be the point.
so if you are plotting PMFs,
Hmm.
then only at x equal to c you would have 1.
Okay, okay.
Okay, anything less than c, greater than c
Hmm.
would be 0.
Okay.
All right, fine. Uh, all right. Oh, also, before moving on to this thing, I would also like to discuss about some properties of variance, as you might have learned. If you have variance ax plus b, this you can write as a square variance of x plus variance of, yes. So if you have a change in the coefficient, if you have some coefficient attached with any random variable, that coefficient will become square when you compute the variance. But if you have something if you have expectation of ax plus b, then this will be a of expectation of x plus b. Okay, so variance is unaffected by uh, anything plus or minus. Okay, that is not going to affect this thing. If even if you have cx minus d, it would be variance of it would be c square into variance of x. All right, but for expectation, even if you have cx plus d or cx minus d, it would become c into expectation of x minus d or plus d, however you want it. Okay, so if you have something like this, let's say x be a continuous random variable with this PDF. If y equal to 2 by x plus 3, find variance of y. So here you see, oh, 1 second. So variance of y, you can write it as expectation of x is expectation of so variance of y is 2 into 1 by
Integration.
x plus 3, variance of this quantity. So this you can write, since 2 is a scalar quantity, it is similar to ay plus 3. Okay, so this you can write as 2 square into variance of 1 by x. So this would be 4 into variance of 1 by x. Is this part clear? Now you have to solve this part, 4 into variance of 1 by x. So variance of any gx is expectation of 1 by x square, gx square, minus expectation of 1 by x whole square. Okay. Then you just have to calculate these expectations and get the value. So here expectation of 1 by x square would be how much? 1 by x square gx into fx dx, and this is true only when x range between 0 to 1. So this x square will cancel. We would have 2x plus 3 by 2 dx 0 to 1. So this would be x square plus 3 by 2x 0 to 1. 1 plus 3 by 2, that would be 5 by 2. Okay, so this would come to 5 by 2. Alright. Again, expectation of 1 by x, this would be gx 1 by x into x square, and what was it? 2x plus 3 by 2 dx 0 to 1. So 1x cancels. We would have 0 to 1 x into 2x plus 3 by 2 dx. This we can write as 0 to 1 2x square plus 3 by 2x dx. This would be 2x cubed by 3 plus 3 by 2x square by 2, 0 to 1. So this would be 2 by 3 plus 3 by 2, 3 by 4, 12, 4, 8 plus 9, it would be something like 17 by 12. Alright, so the required answer would be 4 into 5 by 2 minus 17 by 12 whole square. And whatever you get, that is the required answer. Is this clear?
Yes, ma'am.
Okay. So the important thing to remember is that whenever you have some function of x along with some coefficient and plus minus something, if you are to now if you had been asked expectation of y, that would be 2 into expectation of 1 by x plus 3, and then you have to calculate the expectation either from the PMF or from the PDF. Okay. Let us move on to this question. So if the question is, we have a continuous random variable, okay, and the range of x is 0 to 20, this is the PDF. Find the values of mean and variance of 2x. Now here your y is 2x. So expectation of y would be 2 into expectation of x. So how would you calculate expectation of x? This would be 0 to 20 x into 1 by 20 dx. So it would be 1 by 10, 0 to 20 x dx, 1 by 10 x square by 2, 0 to 20. So this would be 20 into 20 by 10 into 2. So it would be 20. Alright. And variance of y would be 4 into variance of x. And how would you calculate variance of x? Variance of x would be expectation of x square minus expectation of x whole square. So let us now calculate this. Variance of x would be expectation of x square minus expectation of x whole square. We have got expectation of x. Expectation of x square would be 0 to 20 x square. Fx would be 1 by 20 dx. So this would be x cubed by 3 into 20, 0 to 20. So this would be 20 into 20 by 3. Alright. So then variance of x would be 400 by 3 minus 400. Is it possible? Am I doing everything correctly?
Ma'am, I think it is 100 by 3.
It will be 100 by 3. Somewhere I made a mistake. Wait. Yeah, the mistake was here. Expectation of x is square minus expectation of x, not expectation of 2x. So expectation of x was how much? 2. Expectation of
10.
y by 2.
10.
It would be 10. So yeah, here we would have 10 square. So this would be
100.
400 minus 300 by 3. This would be 100 by 3.
100 by 3. Yes.
Okay. This is variance of x. Now variance of y would be 400 by 3. It would be something like this, 133.32. Right, no? 400 by 3. Yes, 133.33. Do you get my point?
Ma'am, can we do first we can calculate the mean and variance after the finding its solution we can multiply it by 2. Is it the correct way?
Actually, we are doing it like this only, but it's not always multiplied by 2. If you have to find out mean, so you find out mean and variance of this thing. That exactly, that is what I'm doing. If you are finding out mean of 2x would be 2 into expectation of x, and variance
Yes.
of 2x, you will have to find out variance of x and then 4 into variance of x.
Okay.
Same thing. That is what we are doing, but I think I was going to and fro, so you were not able to understand. So that's what I did. I calculated variance of x and then multiplied it with 4. And similarly here, I directly multiplied it, calculated x in
Okay.
this part,
Okay,
and then I
got it.
multiplied
You
with,
in
I
the
did it
starting
in,
you
I
do
did
the
it in
same
one step.
Okay.
This is the same thing. Alright? Okay. So let's move on to the next one. So the question is, let the continuous random variable x denote the current measured in thin copper wire in milliamperes. Assume that x ranges between 0 to 20. Assuming that the probability density function is this, what is the cumulative density function of this? Okay. So cumulative density function of this. So probability x less than equal to x is nothing but minus infinity to x fx dx. Alright. So here, since x ranges is 0.05 from 0 to 20, we would have, where fx is non-zero, 0 to x 0.05 dx, given that 0 less than equal to x less than equal to 20. So this would be 0.05x when 0 less than equal to x less than equal to 20. Alright, so the cumulative distribution function of x is either this one or this one. It is this one. Is it clear? When x is less than 0, we don't have any fx. So it is 0. Cumulative density function is 0. Okay. When x is 20, x has touched 20. So let's say f of 20. Here it would be 20 into 0.05. So it would be 1. And anything between 0.05 to 20, we would have 0.05 into x. Okay, so it doesn't matter if we put an equal to sign here or an equal to sign here. Sorry, this would be greater, so here there's a problem. This would be greater than equal to 20. Alright, there's a mistake in the signs. Do you get my point? And also one more workaround is that fx is ddx of capital Fx. So that thing is also satisfied here if you see the other way around. So when x is between 0 to 20, fx can be written as 0.05 into x. So ddx of that would be 0.05 as is represented here. And this holds even when x is equal to 20. Is it okay? Any doubt here? Okay, if not, then I'll just move on to the next one. Alright, so here, okay, I have been given this bigger data frame and I have to find the second and fourth raw moment of this temp time. So I have already entered the values over here in this temp time data. So if I have to find the raw moment, second and fourth raw moment, can you see my RStudio screen?
Yes.
Okay. So at first what you have to do is install.packages moments, and then you have to load the library moments into your console, and then we have to find out the first, second and fourth order moment. So since we need till order 4, order.max we'll put 4. And here since we are calculating raw moments, we would put central equal to false. If we run it, then what we see, this 2178.32 is the second moment and 5360661 is the fourth moment. So this would be
Ma'am, please repeat.
So here when you do all dot moments temp time, order dot max equal to 4, and since we need raw moments, we are going to put central equal to false.
Okay.
Okay, and then when we run it, we get something like this. We would get 5 figures. Alright, so the first figure is always this one. So let me copy this.
Ma'am, it start from origin, no?
Yes.
First one will
Yes, the
start from
first one
origin.
will start
Okay.
always from origin.
Okay.
So this one that we have here, this one will always be 1, and it is representative of mu 0 prime, which is nothing but 1 by n, or I would rather say expectation of x minus x bar whole to the power 0.
Okay.
Okay, this would be mu 2 prime, and this would be mu 4 prime. So this is the answer. Okay, all right. Then they are asking, find the second and third central moment of this data, temp time. So second and third central moment, extremely sorry, this is raw moment, right? So this would be expectation of x to the power 0, not this. This is not central moment, so we shouldn't write it in this manner. Really sorry. This would be expectation of x to the power 0. Alright. Here we are considering the same temp time data, and they are saying find the second and third central moment of this data. So second central moment is mu 2. This is nothing but expectation of x minus x bar, or I shouldn't write x bar, I should write mu whole to the whole square. So this is nothing but actually variance of x, and mu 4 is expectation of x minus mu whole to the power 4. Now let us just find out these from R. So when we are asked to find out the central moment, we just have to give all dot moments, the vector where we have entered our data, order dot max equal to again 4, and the central flag we have to set it to true. Alright, so if we just enter it, so now we have this data set over here. Okay, this is the answer. So now the required values are second and third central moment. This is the 0th central moment. This is first, this is second, and this is third. So it would be this thing, 7.0867 and 7.46 into this one. This would be fourth. Is it all right?
Yes, ma'am.
Okay. So this question says that a fair dice is rolled 100 times. Let xi denote the outcome of the ith roll of the dice and compute the variance of x1, x2 to x100. Okay, so xi can take values from 1, 2, 3, 4, 5, 6, and with probabilities 1/6, 1/6, 1/6, 1/6, 1/6, 1/6, because it's a fair die. Okay, so if I have to calculate variance of xi, it would be how much? Expectation of xi square minus expectation of xi whole square. So we could do 1 square into 1 by 6 plus 2 square into 1 by 6 plus 6 square into 1 by 6 minus of 1 into 1 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6 plus 6 into 1 by 6 whole square. Alright. So how much does this come to? Just find out.
I
This,
think ma'am C 35 by 12.
okay. How did you do it? Did you use any formula? Whole
Same
square.
question was in I think a lecture also. That's why I
Oh, okay,
remember
okay,
that
okay.
value.
Alright. This is 91 by 6 minus, I think I made a mistake.
Ma'am, I can be wrong here. I
Oh,
just
okay.
guess it.
So you just calculate this, no? This is fairly easy. Uh, I am making some mistake over here. Another thing is, if you are aware of the discrete uniform distribution, then what is the variance of a discrete uniform distribution? That is also another way.
Ma'am, this is the example of the discrete function, no?
Hmm. So if we have uh, if we have uh, values like this from A to B with masses 1 by B minus A, and no, this would be an example of a continuous distribution. But anyway, if we have, yeah, 1 by B minus A at, or let's say between A to B we have n points with 1 by n. So then n square minus 1 by B minus, no, by n square minus 1 by
Ma'am,
12 would be variance of x.
78.75.
This one is 78.75. No, it would be more, I think. 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus 6 square by 6. 1 plus 4 plus 9 plus 16 plus 25 plus 36 by 6. This would be this would be 91 by 6 itself, and 1 plus 2 plus 6 by 6 would be 6 into 7 by 6. This is 7. So this so then variance of x would be 91 minus 6 by 7. 91 minus 42 by 6. This would be 11 minus 2, 9. 49 by 6. No. Some mistake I'm making over here. Not able to figure out.
It's 441 by 36, the right hand side.
Right hand side would be 441 by 36.
Yes, ma'am. If we go to the previous slide
Hmm.
and put the formula, and it comes to that only.
This formula you're talking about, right?
Yeah, the right hand side.
Right hand side. Yeah, oh, right,
Yeah,
right, right.
we are subtracting that from the previous part, right?
Yes, yes, yes. Alright. So this would be 1 by 6 into
Denominator
7.
will
Yeah,
be 36.
yeah, okay. Yeah, yeah,
1
yeah.
by 36, right?
Yes, yes. So this would be 36
Yes.
and this would be
And 441, if I'm not wrong. It's coming to 441. Is it whole square, right?
I think it would be 49. 7 square. See, 1 plus 2, 6 would be 6 into 7 by 2. That is 21. Yes, 441. Yeah, okay. So how much does this come to? 9 into 6, 6. 9, 6 nines are 546 minus 441 would be 5.
105 by 36.
105 by 36. That would translate to 35 by 12. Yeah. Yes. So it's matching. 35 by 12. Alright. Now we have to find out variance of x1 plus x2 plus x100. Okay. Now the thing is, a fair die is rolled 100 times, they are saying. This is variance of xi. So variance of each of the xi's is 35 by 12. Okay. Now, all the ith trials are independent. Like whatever will come up in the first trial is not depending on what will come up at the 100th trial. Do you agree?
Yeah.
So, if you have independent trials and variance of these things, this variance of x1 plus x2 plus x100 would translate to variance of x1 plus variance of x2 plus variance of x100. Okay, so this would actually be 100 into variance of xi. So that would be 100 into 35 by 12. And how much does that come to? So this would be 650, 0, 25, 2, 5, 1750 by 6. Okay, this can be further broken down into 25. So 25 into 35 by 3, 25, 125, 15, 1, 7. So we have 8, 7. So this would be 875 by 3. That is the answer. But one thing you have to be very, very careful. Here, variance of summation xi is summation of variance of xi only when xi's are independent. Okay? If not, variance of x1 plus x2 would be variance of x1 plus variance of x2 plus 2 covariance of x1 and x2. We have one covariance term which you'll learn about later, but this is 0 when x1 and x2 are independent. Okay, what do I mean by independent? It means that whatever value x1 is going to take will not depend on what the value of x2 was. Okay, here since a fair die is rolled 100 times, okay, all the 100 times any number between 1 to 6 can come, and whatever comes in the first roll can also happen in the second roll, and the whatever happens in one trial will not depend on what happens in the other trials. Okay, if we have such a what do I say, a restriction case, then this plain and simple plus variance of this entire sum equal to sum of variances, this will not happen. Alright, so before applying this you have to judge the random variable very, very carefully and find out if the trials are independent or not. Do you get my point? Otherwise we would get a totally incorrect answer. Alright,
Ma'am, can we do this by R command?
this variance.
Yes, ma'am. If we know the samples and the range of like we are rolling it 100 times. If any command for commuting this question.
Command for computing, see, this is a random variable. You can do this experiment and get the variance like this. That would be a validation, but you would not get this exact number. Okay, because this is the true variance of the sample. All right, so if you roll 100 times, this is what you would get, a number very close to this, no doubt about it, but it would not match exactly with this.
Ma'am, in the end of this question, you have told us the concepts of independent. Please repeat that one.
Okay, so let's say here you have here the independence thing is implied. Whenever you have some summation, let's say x1 plus x2 plus xn, some random variable, okay, then variance of x1 plus xn is variance can be written as summation of variance of xi I equal to 1 to n plus double summation I naught equal to j covariance of xi and xj. Sorry. Alright, so there is one covariance term implied. What do we mean by covariance? Let's say I'll take two for an example. So variance of x1 plus x2 is variance of x1 plus variance of x2 plus 2 of covariance of x1 and x2. Covariance of x1 and x2, it is written as expectation of x1 x2 minus expectation of x1 into expectation of x2. Okay, this is the formula. This is the generalized formula when x1 and x2 are not independent. What do I mean by independent? I mean that values of x1 or x2 will not depend on what the other variable is taking. Okay, so let's say if I have something like this, x1 is number of defective, I'll take the TV set example. Okay, let me have 100 TV sets, out of which 7 are defective. Okay, and I am defining x1 as number of defective TV sets, and I am choosing, I'm conducting, or rather I'm not choosing, I am conducting 3 trials, and xj is number of defectives in jth trial. Okay, so x1 is number of defectives that can come up in first trial, and x2 is number of defective TV sets in second trial. Okay, now let's say in x1 I have already picked up one, x1 has taken sorry, I'll just frame it a little properly. If okay, and the condition is x1 is number of defective TV sets in first trial, then if let's say in the first trial, if I have already taken one defective set in the defective TV, in x2 I could only have values between, when x2 given x1 can only take values between 0, 1 to 6, where x1 can take values between 0, 1 to 7. So whatever I am choosing in x2, that probability of getting a defective set in the second trial would be different than the probability of getting a defective set in the first trial. So what is happening, x1 and x2 are not independent. x2's outcome is going to depend on what x1's outcome was. Okay, so if x1 is taking a value 0, x2 can take values between 0 to 7. But if x1 has already taken a value 1 and we are not replacing the defective set into the defective TV set into the population again, then x2 will not be able x2 cannot take values from 0 to 7. It can only take values from 0 to 6 and with a different probability. Okay, so in such scenarios x1 and x2s are not independent. But in this dice example that we saw, here whatever outcome is coming in the 100th trial, it can range from 0 to 6, 1 to 6. That is the outcome for each and every trial, and it does not really depend on how we are conducting the trial or what has come up in the previous rule. So in that way, those two random variables are they are independent. Is it
Okay, ma'am.
something? were you able to understand what I'm trying to say?
Yes, ma'am.
Okay. So that's the thing. If outcome of one trial is not dependent on the outcome of the other trials, then only we say it is independent. But if outcome in one trial is being is get is depending on what the outcome was in the previous trial or any other trial, then we cannot say that the variables are independent. And when it is not independent, we cannot use that variance, sum variance of sum equal to sum of variances. Okay.
Okay.
Okay. All right. So here again we have been given data, and we have been find out to get the coefficient of skewness gamma 1 moment of this data in temp time. So if we just give skewness, we are going to get this 0.1250483. Is it okay?
Yes, ma'am.
All right. Yes, do you want to say anything?
Ma'am, in assignment 5, mm, there is one similar question of you just told us the question of independent variable. So could
Hmm.
you please help me out with the same question? Question number 8. Question number 8. A coin is ties and reward of rupees 1 is given if the heads comes,
Hmm.
or 2 if its tails comes.
Hmm. I solved a very similar question, right? So I'm not supposed to discuss assignment questions before the deadline. So if you just try
Okay.
to solve it. If you can't, after the deadline, I will discuss this. Okay?
Mm,
All right.
okay.
Okay. Fine. Let's move on to the next one. So this skewness command in R is directly giving me what is the intended measure. This is something you have to be very careful about. We have been asked to give gamma 1, and skewness in R, this reports gamma 1. But what if we were asked something else, let's say we were asked gamma 1s, then you have to get gamma 1 from here and modify accordingly. Do you get my point? So do you remember the different or relationship between gamma 1 and gamma 1s?
SQRT, square root of the gamma.
Yes. So gamma 1, yeah, okay. So gamma 1 is no, not gamma 1 is, sorry. Gamma 1 is plus minus square root of beta 1, and beta 1 is given as,
Beta 1.
yes, and beta 1 is given as mu 3 square by mu 2 cube, right? So this one you could give all dot moments order central equal to true. You can get it like this if you are asked beta 1. Okay. For here we are directly getting beta 1 gamma 1 equal to plus minus beta 1. If gamma 1 is greater than 0, it means it is positively skewed. And if it is gamma 1 is less than 0, it means negatively skewed. Alright?
Okay.
Alright. Then what do we have? Okay.
Ma'am, could you please explain one problem of finding the expectation of mean and its variance with the function of exponential?
Okay. So let's say, let us take an exponential distribution fx equal to 3 to the power minus 3x if x greater than 0, 0 otherwise. Okay, so expectation of x would be 0 to infinity x into 3 to the power minus 3x dx. Okay, so here we have 0 to infinity 3x e to the power minus 3x dx. Now when you have such functions, you have to remember a rule I late. Okay, so this one stands for exponential functions, this stands for trigonometric functions, this stands for arithmetic functions, this stands for logarithms, and this one I forgot, this one stands for, I'll just check.
Function, huh? Inverse.
Yes, I think this stands for inverse. Okay, so you have to remember this method and act accordingly. So 3x here, or x for that matter, is arithmetic
Okay, ma'am.
function,
We have to
and
apply the basic
exactly
integration
integration by
formulas
parts.
here.
Yes, you have to do
Okay,
integration
okay.
by parts.
Okay, got it.
This one and this is your exponential function. So if you don't remember, I'm
Okay.
just going to tell you. If you have uv dx something, so u integration of v dx minus d du of u, d dx of u into integration v dx, where u would be your arithmetic function and v would be your exponential function. So instead of u, you would put here x or 3x, and instead of v, you would put e to the power minus 3x. And after solving everything, you should get expectation of x as 1 by 3. Okay,
Okay, ma'am.
just solve
Thank you.
this exercise and try to see if you get expectation of x as 1 by 3 or not.
Okay.
Alright. Here again, we have been asked to find the coefficient of kurtosis, that is B2. So for that matter, we will have to go to this kurtosis and type kurtosis, give the name of the vector, and we would get the required answer. Where is it? 1.891, this one, if I'm not wrong. Yes. All right. So how, if you have to comment whether this is leptokurtic or platykurtic, what would you say? So if you have to remember beta 2, if it is 3, then it is meso. If it is greater than 3, then this is this is lepto. And if it is less than 3, then it is platy. Now one more thing, if you are asked find the coefficient of kurtosis gamma 3 or gamma 2, then you would have to do a beta 2 minus 3 and then you have to report your answer. So be very careful what the measure is asking, because our kurtosis, where is this cursor? So this command R kurtosis is going to give you beta 2. Alright, this is going to give you gamma 1. Alright, if you need to transform and you can get the values from here, but otherwise you have to calculate from the moments distribution or do the necessary transformations to get the coefficients in the desired format. Is it okay?
Yes, ma'am.
Okay. So now if you have to find out third and sixth deciles, so to find out deciles, what you are going to do, you just have to know about this function called quantile. By default, quantile is going to give you the quartiles of the distribution. So this is going to give you quartiles. What do we mean by quartiles? Quartiles means it comes from quarter. Quarter means 1/4. So quartiles are going to divide your distribution into 5 equal halves. It will specify 4 points such that it will represent those points, like the first quartile will represent how many that number below which 25% of the population lies and above which 100% of the population lies. Alright, so if you do a range of this temp time, you see the lowest value is this 30.7, highest value is 59.9. So great 100% values lie less than or equal to 59.9 and 0% of the data lies below 30.7. okay, so these points are done. Now if I have to find out the point below which 75% of the data lies, it would be 52.85. Below which 50% of the data lies, 44.7. This actually is nothing but the median of your data that I was talking about. So if you have very skewed data, if you have to report a measure of central tendency, you should report the median, which is 44.7. You can also use this command. That is also fine. Alright. Now, if you have to find out deciles, what do they do? Deciles divide the entire data set into 10 parts. So if you run this command, you will have how much of the data, which is the data point below which 10% lies, which is the data point below which 60% lies, and so on. Okay, so these are the deciles. So in order to activate deciles, all you have to do is you have to specify probability. Okay, probability is equal to sequence 0, 1, 0.1. So what does this do the sequence command, this is going to generate a sequence starting from 0, ending at 1, and the difference would be between each of the two consecutive numbers would be 0.1. Okay, so if you specify this entire sequence to your probability, then it is going to give you the deciles. Similarly, instead of 0.1, if you just give 0.01, this is going to give you percentiles. Now, these are all at equal intervals. You could also want something like this. Let's say I want to know the data point below which 35% of the data and 42% of the data lies. So, I am going to give temp time probs equal to C 35, 0.35, 0.67. Okay, so then I get 2 points. Then I get those data points below which 35% of the data lies and 67% of the data lies. Okay, so you can even match it with here. If you have something 67, where is it? 67 is 49.498. Yes, it is matching. So you need not always, I mean, if you need something like this, that the point below which 0.3% of the data lies or something like that, so then you have to make those many sections. It is not necessary that you get all the number of sequences from 0 to 1 in with a difference of 0.003. It's not like that. Whatever you need, you can just specify the probabilities at which you need the given data, that below which how much of the data lies. You just have to specify here and it will give you those specific points only. Alright. If I just give 0.035 and 0.067. Okay. So I can get this below which 3.5% of the data lies, below which 6.7% of the data lies. Is it okay? Is this clear? So for third and sixth deciles, I am going to run this. So third and sixth decile, they are saying no. Third and sixth decile, that means 30% and 60%. So it would be 39.95 and 47.80. Okay. Similarly, here also we have been given some questions. Okay, so here we have been given marks of 200 students and the examination declares a candidate to be admitted if marks obtained are in the top 30 percentiles. So here we have to remember the keyword is top. So top 30 percentile is equivalent to 70 percentile. Alright. So then we have to find out which is the marks where we would get, where the 70th percentile lies. So I already have loaded this marks data. Can you see my cursor? Oh, okay. So I've already entered the marks data set. So if I write quantile marks probs equal to, since this is decile, I don't have much problem. So then 70th percentile is 70.62. So here I have to write 70th percentile is nothing but 70.62. Okay. So which of the candidates will be admitted? Candidate 1 will be admitted because he has scored more. Candidate 3 would be admitted because they have scored more. Yes, 1 and 3. Is it okay? So you have to see if something like this comes, a question like marks, if you are told top 30 percentile, it would translate to 70th percentile. If you are say bottom 40 percentile, then it would mean 40 percentile in quantile. Alright, the interpretation is like this: whatever point you have, below that 60% of the population lies.
Ma'am, you have used here decile or percentile?
Here I have used decile. It
So
is the
in sequence argument, uh, we have to put lower to higher range, right?
yes.
0.1 to 0.1.
No, not 0.1. I don't get your question. See, here I could have easily put this percentile thing, and I could have gotten where is the 70th percentile, 50.72.
Okay.
Okay, so no, not this one. This is for marks, no? I'm going to change it. Wait. For marks. So this is the same thing. 70% is 70.62. Since here also for deciles also I'm going to get 70%, it is easier for me to check like this. If I would have if somebody would have told me that find out how much is what is the 57th percentile, then I would have to go here. Anyway, if I just don't write anything and just put probability equal to probs equal to, let's say, 0.7, I'm going to get the same thing. Okay, it's just for the ease of representation I just wrote it.
I'm asking the argument part. Means in percentile, we are putting the value in the props equals to sequence from 0 to the higher range, 0.1 to 0.01 means 100th time in the percentile part,
So
and the decile part we are putting uh, uh, 0.1 to the higher number, and for the quantile part we are putting 0.75.
for the quantile part we are putting 0.75. No, this is what we require. See, okay, what this sequence command is doing, if I give something sequence 1 to 5 and difference I give 1, it is going to generate a sequence of 1 to 5. If I give a sequence command 1 to 50, difference equal to 2, then it is going to generate a sequence like this, where difference between each of the consecutive
Okay.
terms will be 2. So now since I want I want to divide it, okay? Deciles will divide it into uh, one second.
10th.
Into 10, like 10%,
10th part.
20%, 30%. So if I give 0.1, then between 0 to 1, 1 by, it will divide it into, all you have to do is 1 by 0.1. So it will divide into 10 equal parts. Okay?
Okay.
1 by 0.01, it will divide into 100 equal parts. Got my point?
Okay,
So
got it.
that is how
Yes,
you
ma'am.
have to specify. And then whatever is the easiest thing that you have to, just excuse me for some time. Hello? Okay. Yeah. So that is how you are going to calculate this. Am I clear?
The things are clear.
Okay. So, all right. And also, this is the last question for today. Which of the following can be an outcome of the command rdunif? So rdunif command, to use this you have to install this packages PU per. You just have to load it, and this, what it does is, rdunif 1051 is going to generate, yes, So it is going to generate a number between 1 and 5. 10 numbers between 1 and 5. Okay, range of the distribution. So if we want a if we want to simulate throw of a die 10 times or 100 times, if we want to find out what is if we throw a die 100 times, what the outcomes could be, we can just run this RDUNIF 10061. Alright, so if I do a variance of this RDUNIF 61, now one thing you have to note is that variance command in R comes with a, so this variance command, usually we write it as xi minus x bar whole square. Okay, but in R, the sample variance, the var x, is going to be 1 by n minus 1 summation xi minus x bar whole square. So if you have to get a value of variance, the actual variance if you have to get, then you have to do an n of var x by n minus 1. Sorry, n minus 1. Sorry. So what you have to do is n minus 1 by n into var of x in R. And n, how will you get? N you will get by length of x. Okay, so here if I want to get n, I would have to give length of, let's say, marks. So that is 200. Okay, var of marks is 852, but we have to remember this is with the denominator n minus 1. So with denominator n, we just have to do a length of marks. So I'll store it in n equal to this thing. So all I have to do is n minus 1 into var of marks divided by n. Okay, so this will be a little less, 848. Is it okay? I'm audible, right? Okay, so yeah, so here, which of the following is an outcome, can be an outcome of the command this thing. So here what we are doing, we are trying to generate, so the number of length of this vector should be, we are trying to generate 6 numbers. So the first consideration is you have to check whether 6 numbers are generated. Here we have 4, so excluded 1, 2, 3, 4, 5, 6, 7, 8, more excluded. We are generating
First
6
one, no?
numbers. Yes. And then this is A and this is B. Okay. So here also we checked RDUNIF 61. So from this we are generating numbers from 4 to 9. Okay, so
First one, no?
this one is excluded because 1 doesn't fall in that range. So first one. Okay, all right. So any other questions, doubts from today's discussion? All right, if nothing, then I'm going to close today's session and I'll see you next week. Do you want to say anything?
Ma'am, little confusion in the part when when we have the mean and variance,
Hmm.
when we are adding and multiplying some constant uh, to the mean, it gets affected.
Hmm.
But for the variance part, it is remain unaffected.
Hmm.
Means the variance will be unaffected with the constant and the multiplication and the addition of the constant. This is the concept, no?
It will not be unaffected by multiplication or division. It will be unaffected by addition or subtraction.
Okay.
Okay.
Means multiplication is applied to the variance.
Yeah, any change in scale is going to affect variance. Multiplication
Okay.
or division is going to affect, plus minus is not going to affect. All
Okay.
right. Oh, okay, coming back to Ankita's question. So whatever functions you learned today, no, you try to simulate this. You make a few columns x, y, z. Okay, k1,
Right,
k2,
ma'am.
something like this. Okay, make a very large data set, import it into your function, save it as a
Okay.
CSV, do data equal to read.csv, and then enter your file path
Okay, ma'am.
here. Okay, so this will save it as a data frame. All right, if you get this as a data frame, it would be something like this. Okay, with different columns. And then if you have to subset this data frame, I want to subset, let's say, x doll. I have this variable. I'm going to I installed this. Where is this thing? Okay, I am going to rename this as data. Okay, so data has 90 observations on one variable. So then in order to extract the first column, you just have to do data dot variable 1. Okay,
Okay, ma'am.
data
Okay, ma'am.
dollar column name 2, or this comma representing all rows, number of the column. Okay, and then you apply all the functions that we learned today to these data sets. You can even import up to R will not hold, like you can go up to 5,000, 10,000. I think it'll load it in a relatively smaller amount of time. All right.
Okay, ma'am.
Okay, you
Okay,
just
ma'am.
enter it in a data frame, save it as a txt file or a CSV file. If you save it as a CSV, you can directly do it. Even if you save it as a txt, if you just give sep equal to tab, it is going to directly load from your txt file. Alright, you just try this out,
Okay, ma'am.
and if you face any issues, you can post it in the YouTube channel or in the discussion forum, and I'll see how to address this. Alright,
Sure, sure, ma'am.
okay, thank you so much for joining. Uh, Somebody else is also joined. Unfortunately, the session is about to close now, sir. So I would request you to join next week. All right? Okay. Thank you so much. I'll see you next week. Bye bye.
Thank you, ma'am.
Thank you,
Thank you,
ma'am.
Have a
ma'am.
nice day.
Thank you.